Hello everybody, my name is Saket and today I will be presenting a presentation on time-delay neural networks and hidden Markov models.
What's your name?
In this presentation I will be covering what time-delay neural networks and hidden Markov models are, how learning in those model works and comparing it to different models. So time-delay neural networks is basically a neural network. It was used to approach phenome recognition. Phenome recognition is basically the ability of AI models to take in audio inputs and transcribe the audio inputs that the user gives them. It uses a three-layer arrangement of simple units. This three-layer arrangement allows it to form decision surfaces. Basically, if you have, say, the letter A in the audio input, all the letters will be grouped together in one side of one feature side, and all the other letters, say B, will be grouped on the other side, which is divided by a decision boundary. The time-delay networks enable the network to discover acoustic phenolic features. Acoustic features are the physical features like frequency, volume that this audio has, and phenolic features are the features like how the word sounds when you put two letters together, and such features. It is chronological independent, which means that it takes the values one after the other, and it is also time independent, which means that no matter where the letter or consonant is there in the audio input, it will recognize it no matter what. Time-delay neural networks are better than hidden Markov models because they can develop recognition features and patterns like F1 and F2 on their own without user input or learning directives. Neural networks do give mixed results. This is because of the dynamic nature of speech, and it is hard for models to understand audio inputs. So time-delay neural networks. It should have multiple layers. This is so that it can form decision surfaces on its own. It should be able to represent relationships in time between events. Basically, it should be able to understand words and characters one after the other. Actual features should be invariant at the time. Basically, no matter where it is in the time, it should be able to recognize the vowel. Learning procedures should not require precise alignment. Basically, the learning method should not tell it how, when, or what the sound is. It should be able to recognize the sound on its own and learn this on its own. Number of weights should be small compared to the data. This is so that the model is forced to train again and again and again, and accuracy improves. Learning in time-delay neural networks, it uses backpropagation, which is basically it adjusts all weights to decrease error in output. Basically, time-delay neural networks, there is a set delay time, say t, and if you have a certain take a time t, it will take in all inputs before that from t minus 1, t minus 2 all the way to t minus n, and it will read all of them at once. This is why I call time-delay neural networks. Since all the units are searching for the same event or the same sound, the weights should be same. If the weights are different, that means that the network is biased, and say they have two moments in time a and b. If it independently calculates the weights for A, it calculates the weights for B. If the model continues learning, if the model does not learn independently, then the weights will go farther away, which is why we take average of the weights and then add the weight loss to each model, each weight. Hidden Markov models, these are partially successful because they deal with variability in speech by stochastic modeling. Stochastic modeling is basically when each person says a word or says features in different ways. They have different speeds and they have different ways of pronouncing certain words. To deal with this, we use stochastic modeling. Acoustic fragment of HNM is usually vector quantizer. So basically, you have a large number of data, each phenome or like each token, which is basically a consonant or the say letter A, for example. Is a data point in a graph. So it groups all the data points of similar types together and groups them in such the graph like this. Basically groups them like this. If each data point, if each one represents D, you will group them like this in a graph. Likelihood ratio, augmented and power values, PWLR. Basically, if there's an audio input, say it's not able to recognize what the audio input is, so it increases the power or volume on its own to be able to compare it accurately. It uses LPC, which is linear predictive coding. Basically, linear predictive coding is helpful because it's able to understand the general shape of the audio inputs, but it fails when it comes to noises and other such items, which is why we have moved on from linear predictive coding. The flow values just set on output probabilities to avoid error caused by zero probabilities. Basically, in hidden Markov models, you multiply probabilities together to get the final value. If probability of a certain letter occurring becomes 0, then the final output will also be 0, which we don't want. So we take the value to be very small, 10 power minus 8 of the order or so, and we deal with them in log form so that it's easier for them to be calculated. So recognition experiments, no pre-selection of tokens was done. Constants were taken from entire occurrences and not in isolation. Basically, the audio input that was given as sample was not selected based on anything. It was a random audio input which had a variety of audios. The variability exists in audio because of the context and from where it was taken. For example, some letters might be silent during pronunciation of certain words, which is the context from which it's taken, and the position from which it's taken is, if you put H after S, say you won't pronounce it as H, you pronounce it as SH. So for that reason, there will be variability. Time delay neural networks has a tendency to fire with large confidence. Basically, in time delay neural networks, or even if it's not 100% sure if that output is that character, it will still fire and give the point in the graph. We do not want this, and most models usually fire only if they are 100% sure. So we reward the time delay neural network if it fires with 100% accuracy. Otherwise, we do not reward it at all. Network learns to link variations in sensory input to saying. Basically, if two people have completely different ways of pronouncing a certain word, the network might take a longer route for the harder pronunciation, but in the end, it reaches the same word and is able to accurately tell you what word or what value that is. Time delay neural networks and hidden Markov models are able to do one thing correctly. Basically, after all the data you give, after all the data training and all the data, it is able to accurately predict one letter or phenome in an entire series. So yeah, the conclusion is basically implemented abstractions in time and frequency. Basically, it's able to recognize, it developed its own features like F1 recognition and pattern recognition on its own. Links to different acoustic events with same higher level concepts. If two people have different ways of pronouncing it, it's able to link them and reach back to the same word. This translation variant does not rely on precise alignment. The user does not have to tell it how it works or what it does. It's able to develop the sounds on its own. Any questions? Basically neural networks, if you go to so basically neural networks, we have certain letters say A. So say if the letter A appears multiple times in a certain audio, since it's appearing more times, you will assign a higher weight to it because it's more important. Otherwise there will be a lower weight assigned. We want to keep the weight same as probability of sounds in audios are rare, but it's always possible, which is why the weights are kept same. Time delay neural networks, because of the fact that it can take the previous values, it's used in stocks analyzing and all the other features, because it can take in the past 10 days input and accurately analyze the pattern of how the stocks is going. So because of that, it's used in stocks trading. Hidden Markov models, because it's able to individually break down each thing and look at it individually, it's used in DNA strands, where it's able to identify which DNA strand is which.